All right. So I just posted a video related to just some notes and observations related to color theory and linguistic relativity. I'm still working through just kind of unwinding myself from this line of inquiry. So I also wanted to post a video just to um, roughly document some of my thoughts and my hypotheses related to the area. Understanding one that this is though I've read quite a bit of academic research as I've been thinking about this, uh, nowhere near what I would need to have well formed theories about what's going on here. So all of these theories should be taken as, excuse me, my my current but uneducated and incomplete and not well formed thoughts about what's going on here. So just wanted to lay out that preface because I'm going to be saying things that may seem strange when looking back on it in the future. So, given that, again, I'm just sort of going to be rambling, thinking through, or talking through a number of things that I came to believe as I was doing study into linguistic relativity and color theory. So, I want to start with this concept. So, on the left hand side of this slide, I'm showing the 11 basic color terms of the English language. And then I've juxtaposed that with the McAdams ellipses on the chromaticity diagram on the right hand side. So basically, or very quickly, linguistic relativity, especially when we're talking about a strong form of that, closer to linguistic determinism, suggests that the words that you have available to you in your language somehow fundamentally changes how you perceive colors. So concept here would be your I think the original thing that was noticed going back to Gladstone and Lazarus Geiger in the 19th century was uh, ancient ancient people appeared not to have a word for the color blue, and the hypothesis was that for some reason they couldn't see the color blue. What we found in subsequent studies, as an example, native Russian speakers have 12 basic color terms. They actually have a light blue and a dark blue. I'm not going to even try to pronounce the words for those, but they actually see that light blue and dark blue as distinct as we see like red and purple. They don't have one word for blue like we do that would encompass both of those. They see them as two separate things. And research has found that native Russian speakers are better able to differentiate between shades of blue than native English speakers. Another very commonly cited study has been that related to, I think it was Davidoff, his studies related to the Himba tribe in Namibia. The language used by the Himba tribe in Namibia does not contain a word for the color blue, but they do have a number of words for the color green. And what he's found is that they are. So the study that I've seen was basically he flew to Namibia and ran some tests with the people of the Himba tribe, and he would present them with a circle of 12 colored tiles, and 11 of those colored tiles would be something we would recognize as green, and one of those colored tiles is something we would recognize as blue. And when you if you were an English speaker would look at this and ask to pick out the tile that was different than the others, you would seemingly without thinking immediately pick out the one blue tile. But the speakers, the members of the Himba tribe, when they would look at it, they would struggle to identify it. They couldn't see the difference between the blue tile and the green tiles for some reason. And they would stare at it for a long time. You'd have to assure them that there was one that was different, and then they might venture a guess and potentially be correct. But for some reason, it didn't stick out like it does for English speakers. He also reversed that. So same circle of 12 tiles, except now all of them were green, but one was a very slight difference in the shade of green. And when he would show this to Himba tribe members, they would immediately pick out the difference. And when he would show this example to English speakers, we could not. We would struggle in the same way that the Himba tribe members struggled to pick out the blue tile. So it seems like there is something related to language that, or the words that we have available to us in our language, that changes how we perceive things. So based on that context, want to throw out a couple theories or document a couple theories related to this. Um, Before I do that, let me just say that this is still a pretty hard fought argument, it seems, in academia. Uh, and there is a hard form of linguistic relativity called linguistic determinism, which basically says that the language itself is changing your perception of color phenomenon. And I think they call that categorical perception. That something about the categories in your language changes your perception of colors that you actually perceive. So here's my theory related to that. I think uh, I tend to believe at this point in a strong form of linguistic determinism. Um, my guess is that that there is a parallel between how artificial neural network classifiers learn to differentiate between the categories they're trained against, and how we as humans learn to differentiate the colors that exist in our language. I think there's very clearly something below that there is a biological default way to perceive colors based on the physical inputs. But I think the language that we have and the words that we have in our language helps us fine tune that and can adjust how we actually perceive colors. Having said that, my intuition also suggests that there is I would assume that there is a critical period in our lives that actually allows us to fundamentally change how we perceive colors, which I'll dive a little bit into. So there's also been some research given that related to the research that was done with native Russian and Turkish speakers and Himba tribe members. There's been similar research to see if you could arbitrarily create new names for colors or basic color terms, train adults against that. So as an example, if I were to carve out a space of this portion of the color space and call it FizzBuzz, and if you were then to train adults to recognize and differentiate shades of color within the FizzBuzz basic color term, they've done that experiment and found that with relatively little training, people will, the people that studied the FizzBuzz portion of the color space as though it were one of the basic color terms, their ability to differentiate in that portion of the color space became significantly better. So, just trying to make sure I'm capturing what I want to say here. So, here's the thought. So, if we were designing a classifier, artificial neural network, convolutional network, to be able to classify between cats and dogs, the way that the classifier essentially does that is it learns the differentiating features between those two classes, and essentially, one way to say it would be that it learns the in-between of those two categories. So it could, for instance, learn that based on the training data that it has, that all dogs have a longer snout and all cats have a very short snout. So that when it saw a new photograph of cats and dogs, maybe it learns just to focus in on the snout or the length of the snout and make its prediction or its determination about that. So it focuses on the differentiating features, in this example, the snout of the animal, but doesn't focus or pay attention or much or any attention to the features that do not help distinguish or differentiate the two classes of cats and dogs. So if the fur always looked relatively the same or the same color or the same length, it would just never pay attention to the fur. It wouldn't learn to pick up on any features that are inherent in the fur of the photographs when it tries to make a determination of what category it belongs to. So if you try to transpose that onto how we perceive color, and imagine that we do have something somewhat resembling an artificial neural network in our head that is trained to classify against these basic color terms, or let's reduce it significantly and say that we're just training to classify black, white, and red. Um, so all of these other colors we do not have in our language. We just have three terms: black, white, and red. So the artificial neural network type thing that we have in our head would learn to differentiate between those three colors. It would learn based on the tri-stimulus input that we have coming in from our senses. What are the features of that tri-stimulus input that help me differentiate red from black? And it learns the in-between. It learns the boundaries of those that throughout the training process. So now imagine that something that was blue entered our line of sight. It may look like it falls into the black category, right? There may be nothing that differentiates based on what it had to learn to differentiate red and black. There may be nothing, no features of the color blue that that fall in the same portion of features that the model had to use to differentiate between red and black. So it's possible that would just look like a different shade of black to us if we didn't have a word for it. I think that makes sense, and I think there was a study that that I saw cited as a reason why people had moved away from a stronger form of linguistic relativity had to do with the debunking of one explanation of how categorical perception could work. And the idea, the theory of categorical perception, or this stronger form of linguistic relativity, was that somehow the existence of color terms somehow warped or stretched out our perception of different parts of the spectrum. So way to explain that would be, if we had color terms from blue to green, then somehow the existence of those color terms would somehow stretch out the distance, the part of the spectrum that lied between those two things, making it easier for us to differentiate colors on that portion of the spectrum, and maybe compress the portion of the spectrum that lands within the color blue and within the color green. So that somehow there could be this perceptual stretching and compressing of our perception of the spectrum. And basically the paper described an experiment that was run that proved that there wasn't, or seemed to show that there was not, that type of compression or expansion that you would expect to see if that was the reason behind categorical perception. So I think if you think about it in terms of how that this classification process works similar to the way that artificial neural networks learn to differentiate between the categories that you've defined, it seems to me that I've not yet seen anything in the academic literature that would suggest that that's wrong. Everything either would support that theory or at very least would not be able to discard that theory. So that's one theory I wanted to talk about. The other theory is this. So it has been shown that there's been studies that show if you were to choose a portion of the color space and arbitrarily give it a new name and then train against that new name, that you improve your ability to differentiate in that portion of the color spectrum. As an adult, right? As an adult, I can spend 4 hours over the course of 2 days and significantly improve my ability to differentiate between shades of color in that portion of the spectrum that we've added some specificity to. So, question is this. Two questions. One is, if I do that, if I spend the 4 to 6 hours to learn that new arbitrary name, does that fundamentally change the way that I perceive colors in the world? Meaning this. So if we assume that Russian speakers who have two words for the color blue see those two things as being as fundamentally different as we see blue and green, if I were to learn a new arbitrary color as an English speaker, after training on that, would I see that new color as being fundamentally as different as I see the color blue and green. Um, the other thing is this: our language has evolved. The English language has evolved to include 11 basic color terms, and at least for me, subjectively, it does feel like those 11 terms are distinct things. Meaning, I very clearly feel the difference between a pink and a purple. It feels like those are two different things. And though I can appreciate that there are some things that are more pink or more purple, or a combination of those two things, they feel significantly different. If I were to train on, instead of just these 11 terms that we've evolved in our language, what would happen if you were to create an arbitrary, divide the color space into 1,000 different color names and learn that? Like, how fundamentally would that change your ability to distinguish and discriminate between shades of color across the entire spectrum? And to what extent would that or could that fundamentally change the way that you perceive? So here's my theory. Be this. Let's assume that because this visualization is divided into 64 different equal size portions of the color space, assume that we gave a name to each of these 64. And we essentially tried to learn the names and learn to differentiate between each of these 64 different colors. My theory would be that, yes, as an adult, I can do that, and it will drastically or significantly improve my ability across the color spectrum to differentiate between shades of color. And I believe that's supported by some evidence and some research where it's been done on adding one arbitrary color name. All right, this would just be an expansion of that to divide the entire color space into 64 new names. And the second point is to what would that actually do to my perception of color? Would that fundamentally change it? And my intuition says no. If I did that, and as an adult, though it would improve significantly my ability to discriminate between shades across the color spectrum, it would not fundamentally change how I perceive color. It wouldn't be as though I see all of these 64 different shades as being as distinct as I see blue and green today. I'm assuming, I'm theorizing that is also due to a critical period in our development life. So I would assume that if you were to train somebody from birth, that instead of training them on the 11 color terms that we have today in the English language, if you train them against all 64 color names that we've made up, that for them there would be a significant perceptual difference. And the reason I say it is, or the reason I believe that is this: I've done a little work to try to train myself on arbitrary color, and it seems to have that effect. But I also see it as something akin to perfect pitch. So we know that there is a critical period for perfect pitch, that if you do not learn perfect pitch before a certain age, you will never learn perfect pitch. And there's something about learning it in that critical period that seems to have this more profound effect on your perception of sound. But that ability to attain that profound perceptual change seems to be only available to people before that relative level of plasticity in the critical period closes. And then after that door closes, your brain has lost the plasticity that would be required to create that profound change in your perception. So for me, the perception of color, the categorical perception of color, feels very similar to what they've found in perfect pitch. And when we talk about linguistic relativity, they very freely include perfect pitch in that. This isn't anything new that I'm saying. So my intuition is that's how this will work out eventually. Interestingly, though, it has been shown, I think it was in 2013, that historically we've never been able to teach an adult perfect pitch. Or I don't know if there's edge cases or something, but as a rule, an adult could not learn perfect pitch. If they didn't learn it, as a child. In 2013, researchers were able to give adults a prescription of some epileptic drug, drug to treat epilepsy, and after the administration of that drug, those adults were able to learn perfect pitch. That somehow that drug reopened the critical period door, provided enough plasticity of their minds so that they could fundamentally change their perception of sound to the point that each of the names of the notes, which are just arbitrary names for some spectrum or for some wavelength of the sound spectrum, all of a sudden they clicked for them, and then when they heard a sound, they could associate it with a name for the note. So there was something about that drug that opened up the critical period. So it'd be curious to me to see if you were to more profoundly divide the color space and train against that, how that would actually affect adults, how that would affect people prior to the critical period, and to what extent could you reopen the critical period, train against it, and what kind of effect would that have on your categorical perception of color? And I think that's all that I wanted to touch on. I do have some Python scripts, so I actually went through the process of actually equally dividing the color space, a training script against it, and then I had another script that I was using as a baseline for sort of a baseline test. And I'll probably throw those out in a blog post somewhere. But really just wanted to document the hypotheses and thoughts. Completely uninformed and unsubstantiated hypotheses and thoughts in case I return back to it in the future. And with that, I think this video is done.